All right, everyone. So today we're just going to resume. We're just going to try to get through as much of this as possible, SQL stuff. But it would be nice if people interrupt and ask questions as we go along. So are there any questions actually at this point? I'll bring up the chat. Does anybody have any questions? Doesn't seem like it. Okay, I assume people can hear me. Otherwise, I would have gotten some chats. One sec, my coffee's a bubbling, so I need coffee. So I'll be back in just 1 second. So I guess technically this is espresso. So that's very good. All right, everyone. I don't see any questions here. Yeah, so what's the status? What's the status here? So we know what we're going to do for lecture, but let's just maybe talk a little bit about projects. Is there anybody who knows who they're going to be with on their project? Is there any like project leader who has, here, I'll just put it up here. Is there any project leader who has their 4 people underneath them? Raise your hands if you're a project leader who has assembled a team. See, someone I think needs to be muted. No. So I guess nobody's done it yet. Okay, let's be a little more democratic about it. Is there anybody who knows that is there anybody who actually has like a partner that they already know they're going to work with, they haven't yet? Is there anybody who's formed a group who knows what group they're going to work in? Anybody? Okay, good. We got at least one. Yeah. So there's this, I guess, on Canvas, it's called discussions. So I assume everybody got my email. Does everybody get my email automatically? Does the group leader have a different role? Yeah, the group leader is the point of contact with me. So here's a question that went out to everybody. About the project teams, does the group leader have a different role? So is he doing, or she, a different work like organizing more, etc.? Well, the leader is the point of contact with me, especially if anything goes wrong. Like sometimes it's happened that a leader has said that someone on the project disappeared. So I just go in and I say, then they disappeared. So, in other words, if there's a loafer, the leader can report the loafer to me. They also, they have, leadership's a funny thing. With it comes certain burdens and certain privileges. A lot of times leaders don't do anything. They organize and they complain about how busy they are, and they get everybody else to do the work. So that's leadership. It's about that as well. So you might consider that as an advantage, or you might just think it's a burden because it kind of gives you a little bit of extra responsibility. But it's kind of like a dispute settling. I kind of would defer to the leader more than an underling. And you get to be, a leader, you don't need to be called an underling. But I think that most of you guys are probably going to be fair in your group. And you could be a bad leader who is just in this kind of Machiavellian kind of mood and kind of abuses people and uses their power over them. But in this case here, if that happens, then report everything to me, because because this is you guys are kind of starting out, or most of you are, and it's good to kind of get this stuff out and worked out before, before it's for real. But it's kind of a similar. Anyways, I hope you guys understand roughly what a leader. The way I'm saying it, you probably don't want to be a leader, but point of contact. But the thing is that in the meetings, so sometimes when I have group meetings, I'm kind of having more of a hands-on approach now. So if the leader is too weak and hasn't really kind of got people to do stuff, I'll just kind of interrupt and I say, okay, what are you doing? What are you doing? What are you doing? So I can go beyond the leader and then ask kind of at the level of the individuals, what are you contributing? Meetings, by the way, with the full group meetings, I want everybody to be there if possible. And if somebody has a real extenuating circumstance, then they can be excused from it. But when we meet, I want everybody, the leader included, there. Of course, the leader. Anybody have an idea what they want to do? I want to give. I mean, I don't know what. I want you guys to come up with stuff that's creative on your own. I can make some suggestions about. Try to give you some kind of guidance about what I think would make a good project idea. But I mean, a lot of it's going to be about us kind of batting ideas around. But what I would like, ideally, what you would do is you would pick something that actually is useful, that could, in principle, be turned into like some kind of product or service or a website or something that would actually be useful, so that you can make a case for it, right? That it's not just yeah. So I hope that makes some sense. Does anybody have an idea yet so the people who are in groups, does anybody have any kind of rough idea, at least the area they want to do their project in? Anybody? Hands, maybe? I won't call you out at this point. I just want to get a sense. Are you guys completely blind as to what a project would be? Or, I mean, does anybody have any inkling of an idea?
Hi, Michael, can you hear me?
Yeah, I can hear you. Yeah.
Hey, so I was wondering, I can also turn the camera off, maybe that's nicer. I was wondering if we are required to do a relational database for the project, or can we use any type of database?
I've been kind of wrestling with that question in my own mind. Normally I say that you can use anything, but I'm kind of like thinking maybe that I like to argue. Well, I like to have an argument about that with people because whatever it is they pick, my position is basically going to be whatever you're going to pick sucks compared to relational. That's after my experience, that's my default assumption, is that everything sucks except for relational when it comes to databases and building systems. I mean, but if you say, oh no, we want to do it we must do it in MongoDB. We really want to do it in MongoDB, and then we argue about it, and I say, but you really need to do it in MongoDB. Do you really want to do it in MongoDB? MongoDB is terrible to set up. I mean, it's and also it's just, does MongoDB really have legs? Is it really gonna go the distance? Cambro was on MongoDB, and look what happened to Cambro. It's over. But anyways, I mean, but I want to have an argument about it. But you know which system you're thinking of?
No, not really. I'm just wondering for different use cases.
Whatever it is, I'm going to take a big bite out. I mean, I'm going to start chomping on it because I'm very opinionated about this stuff. But the thing is that just because I'm very opinionated doesn't mean that we can't run successful projects with you guys using alternatives to the relational model. I mean, in fact, it might be a great project because you'll show that I'm this kind of narrow-minded idiot who is too stuck in my ways about relational. But it just seems to me, I've been around the block a little bit about the relational stuff, because it always happens that this new ideas come out, they flop around and they kind of seem new and interesting, and then they get sucked back into the relational empire. So it's just, that's where I'm coming from.
All right.
Like all these people like spouting about this big, this wide table. Like even Google now has gone back. They've taken this big table thing. They're going back to SQL. I mean, it's just everybody's reinventing the wheel, and it's not even around. Okay, that's my basic complaint. But I'm opinionated.
Okay, thanks.
Sorry, I'm not sure if you wanted to hear all that. Okay, am I recording? I better be recording here. Yeah, I'm recording. Okay, so are there any other? So that was a good question, but I'm going to try to put people back into relational. And then if you want to say, well, we want to use MySQL, okay, fine. But I would suggest use PostgreSQL because it's I think it's got the most muscle of all of them. So yeah, but that's my opinion. But again, I hope you guys understand. I'm not the type that gets upset because someone goes a different way. I mean, I accept. I accept it's your autonomy. You're the one who runs the project, but I can be a critical voice that tries to kind of guide things. But all right. Anyways, enough. I'm kind of wasting time here. We're going around the block around this. But the thing is that I really want people to like start bouncing ideas toward me. I mean, I've given a fair bit of time here. Let me look what the schedule says here. But getting the projects right is really a critical part of this. It's like half the course, so it's really an important part of the course is to kind of get an interesting project set up. So what do we have here in terms of the time? We have we've got quite a bit of time because what is it? What's today? Today is here. One second, lectures. Today is the 3rd, and we've got until. Basically, we have until the end of the month, and we have until October 1st to get these things settled. But I would like to have things settled much earlier than that. I'd like to start kind of getting proposals accepted earlier. So I just wanted to put some delay in there because I want us to kind of bounce ideas around. So if you have an idea, put it in the chat right now. Send me an email. This class is not going to be that big, so we can have a lot of discussion around things. Okay. All right. So let's see, what else? Are there any other questions about things? I imagine there's a question that kind of is people are just like wondering, like, what does he really expect about the reading? And I've looked a little bit at it. Let me just go here and show you guys, because let's be honest here about like the utility of, I mean, I'm going to go over the SQL stuff today, but it's not really that. I'm not really sure how useful what I say is when it comes to me covering SQL, but I'm going to do it anyways because I want to for us to kind of get it. But let me just be alongside. Let me share my screen here first. Share screen, and then share that screen. Share. Okay, so you guys can see this now. So let's just do a quick kind of survey of this. This is kind of, okay, I will provide a very specific list of what you must read very soon. Okay. So really, if we go here, I want you, I mean, you might think, well, I want you to read pretty much everything in the preface because it's so short and it gives you a little bit of historical context. I mean, the PostgreSQL is coming out of Berkeley. It comes out of Stonebreaker. Michael Stonebreaker is the name. So there's not that many names that I'm going to ask for you guys to. I mean, there's a couple names in databases you need to know, I suppose. There's Ted Codd, right? So Codd is the kind of the innovator who invented databases at IBM back in the 70s, essentially in the 70s. And then there is, well, there's not that many more that you have to. There's Tim Gray who did all the transaction stuff, but we'll cover that later. And then there's Michael Stonebreaker, who's one of the great innovators in database systems. Stonebreaker did at Berkeley. Stonebreaker did Postgres, and Postgres became PostgreSQL after Stonebreaker did a commercial. He commercialized Postgres, and it got sold to IBM through Illustra or whatever. But there was another fork of the code that went and became Postgres. So and then things kind of got built on top of that. And since it's Berkeley, and as we all know, Berkeley, I mean, what else? What was the other thing that came out of Berkeley that was the big kind of computer science systems innovation? Does anybody know what else came out of Berkeley? Well, Unix, basically, or the BSD, Berkeley Standard Distribution Unix. So there was a lot of innovation with Unix at Berkeley back in like the 70s and 80s. It started at Bell Labs, Linux, Unix, but Unix, right? So everybody says Linux now, but let's be honest. Linux is derived from Unix, all right? So Unix was where the brains. Well, Linux, of course, Torvalds, all props and all that to him, but the basic approach and all that stuff, it came from a lot of things were developed at Berkeley there as well. So there's a very C flavor. There's a lot of PostgreSQL is written in C. And a lot of the, it's very kind of BSD kind of based, or at least it was. So it's very much tied to Linux. Kind of, they don't say much about that in here, but that's kind of part of the truth. All right, then the tutorial. I want you guys to read the complete tutorial. I mean, this is really, and there'll be some new things in here, by the way, for you when you read it. So, I mean, when I say read it, I mean, well, read it. Yeah, read this full tutorial. What's the challenge to do this for the project, etc. Yeah, somebody looks like, I just answer a question somebody had about, yeah, you're free to use whatever relational database you want. You can also use a non-relational database, but we want to argue about it. We want to go back and forth about it. And if you want to use a different database, yeah, we can argue about that. I mean, I don't know, maybe, yeah. I mean, sure, MySQL, SQLite, maybe those are some possibilities, but maybe something even different than that, something like SQL Server for Microsoft or something. I mean, you know, we can discuss it. I mean, I'm trying to push everybody toward PostgreSQL though, because I think it's the best free one out there. Sorry to be so rambling, but I have to be, because I've got a lot of things that I want to tell you guys, and they kind of come to me. I've kind of thought about it, and I think certain things I want to also say to people. All right, show of hands here on the participants. I'll move that so people don't have to see what other people say. Has anybody done anything with AWS, Amazon Web Services? Any hands here? Does anybody, okay, is there anybody who has not heard of AWS? So if I put it that way, then okay, I can, now that no hands are showing, I can assume everybody's heard of AWS, Amazon Web Services, right? It's really the first, like, biggest and grandest of the cloud solutions. And it's wonderful. It's absolutely wonderful. AWS is wonderful. So I would really, and the thing about what AWS is also nice is that you'll get, like, you can have 1 year of free tier. So and since you guys are all fresh and new to AWS, presumably, if you guys sign up for AWS, you can have 1 free year of, of certain services. I hope, but you probably have to give it your credit card. Anyways, because we're a university and all that, I can't, like, tell you guys you have to do stuff on AWS. I just can't say that. I would like to, but I can't. I would really like to say, no, you have to do everything on AWS, but then you guys could very easily complain, and I could very easily get in trouble. Maybe even me talking about AWS like this is going to get me in trouble. I mean, I don't have any interest in AWS. I don't invested in them or anything like that. But it's great. It is great. So it's like everything's like virtual servers. You can kind of, start these things up. You can do everything in AWS. So I would really like to encourage people when they do your projects to do them on AWS if at all possible. And AWS is also, it has RDS, which is like the relational database services. And they really have kind of made, well, it looks like they're putting PostgreSQL front and center as well. So there's a lot of companies, a lot of companies who are migrating from their crappy old kind of in-house systems, like running on Oracle or running on some other rinky-dink database. Sorry, Oracle. And they're migrating to PostgreSQL on AWS. So there's a lot of action there, which means, I mean, marketable skills. Okay. Alrighty. So okay. So that was just a side there about trying to kind of sell you guys on AWS. I hope that registered with people. AWS. If I maybe because I'm just kind of speaking here, I'll just put it like that. AWS. And in fact, maybe I can even go to, like, I better be careful with this because I don't want you guys to see my password or see my, I don't want to have any security lapse here. La da 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 da. One sec. All right. La da 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 da. AWS sign in. Sign in. I don't know how useful this is, but there's, like, I mean, you got so much here. Anyways, you can say, I'm not going to show this because I'm a little worried about it because you can probably see the keys or something. I don't want to do it. So instead, I'm going to go back to here. Anyways, okay, I've said enough about AWS. I probably won't say much more, but if anybody has any questions about AWS, please ask me because it's a great hobby. All right, then when it comes to the SQL language, okay, so these I want you guys to understand completely. And there'll be some new stuff here. Like, for instance, I don't think you guys, has anybody heard of window like window functions before. Anybody heard of that? I doubt it, but maybe. But it's going to be covered in here. So it does actually go over a little bit of installation here too, which I want you guys to be able to do. Some of you, I mean, I think some of you probably already have your PostgreSQL accounts from the school, from the university, but I can say already on recitation number 2, you're going to have to install your own PostgreSQL server on your own computer. I'm assuming everybody has access to a computer. And the reason is that on recitation 2, the database sizes are so big that we cannot run that. We cannot do that on the we'll crash the department servers if we have everybody kind of doing those databases on their department account. So no matter any way you cut it, you're going to have to install PostgreSQL. All right, I guess there's a little bit of an issue about like Windows or Mac. Okay, you can absolutely install PostgreSQL on Windows and Mac. Absolutely. I mean, yeah, I've yeah. I'm obviously, you know, I mean, as you can sense, I'm much more pro Linux, but I've had people that I've dealt with, and it's doable. I've had to do it myself for a couple of them, which is not fun. It's a little bit better on Mac than it is on Windows, but it's not actually bad. It's not bad at all. It's easy. Just get it installed. I mean, if you have a problem installing it, you can ask me, and I might be able to help you. But the thing is, I mean, you guys all know how to get stuff done, right? I mean, you do stuff, and then when it doesn't work, you take whatever the error message is or whatever, and you paste it down into Google, and then you start reading. That's the way you do it, right? So, okay. All right, but anyways, the tutorial, you should read everything in the tutorial. That's like window functions here. That's something that's, I'm sure, new to people, but it's important to understand window functions. We'll cover them later on. But I mean, I'm just saying that you might read the tutorial, you might say, well, some of this is kind of new to me. I mean, it's like, or not new to me. Some of the stuff that I already know, okay? But like, all right, like aggregate, I mean, you might say, oh, I already all know all this stuff, but please just go and read it again so that, yeah, there we go. Yeah, we got a solution there already. I mean, for those people who still run Windows, but okay, fair enough. You know, it's all right. Yeah, so I want you to read all that. Okay, now I also want you to read all of I want you to understand. I want you to become familiar with this documentation so you can find stuff on your own. You get into this right here though, and you get into stuff like the lexical structure and value expressions and calling functions. I mean, this is very technical in terms of kind of really what is, I mean, if you really want to become a master of PostgreSQL, if you want to become a master of PostgreSQL and with that, you could go out and make money. I mean, like, it's not hard to find jobs doing PostgreSQL stuff. So if you read section 2 here down to the nub all the way, you read all of this from 4 to 15, then yeah, But I'll be a little more specific because there's certain things in here that are not really. No, it's all good actually. This is all worth reading. But there's some stuff like parallel query. I mean, some of this stuff gets pretty dense. I mean, so do you read all this? No, you don't read this, but you at least kind of run your eyeballs over the whole thing so that you have somewhere in your head, you kind of know where things are. All right, but there's nothing that like type conversion, for instance. Type conversion, the way types work in PostgreSQL, there is a system of kind of implicit coercion to different types, and this can be. Let's see, is this like an example here? I mean, it gets into this kind of describes kind of what the protocols are around that, and so it's pretty grubby. Type conversion is a pretty grubby section, but well, it's this documentation is very well written and it's well structured. So I think it's worth. Okay, I prefer Linux, but I have problems with drivers, so I use Ubuntu inside of Ubuntu. Yeah, yeah. Yeah, the thing about that, just to say, with Linux, I mean, what you got to be careful about is what distribution you're using of Linux. I mean, you want to, like, I use Debian, but the thing is that you got to do it from a fresh base, which is always kind of harrowing. But if you somehow corrupt your Linux system, then it can become really bad. I mean, really difficult. And as far as drivers go, yeah, you get the people who are kind of still trying not to do stuff. It depends. I mean, if you want to, like, yeah. Anyways, like I used to play games on my computer, and I would have Windows there because I would, that's the only way I could play games. But then, and also Bank ID. Bank ID used to not with Bank ID you needed to have Windows. It really sucked for a while, but now they have mobile ID, so I was able to kind of completely scrub away Windows finally. All right. And then we'll get to some other stuff here. So basically, I think I'll refer back here, but let me just kind of make a note of it, just so that you guys can see. I would say, yeah, just run your eyeballs over everything up to from 4 to 10. I would suggest running your eyeballs over everything, just to kind of get a sense of where things are and how things are. Like you get into something like the data types. I mean, this is kind of going to be like, let's see here. What's one that would be kind of like this geometry types? These are kind of interesting in a way, but you could skip that. Maybe I'll have a list of things I think you could skip. And there's things I want you to skip, like inheritance. And even inheritance, don't use inheritance. I would suggest not using inheritance. So what's inheritance? Inheritance is, let's see if we go to the tutorial here. Inheritance is, let's see if we got, there it is. All right, so this is an example of something you can do in PostgreSQL. So this was something that kind of goes back. It was, okay, there's a lot I could say about this, but I don't want to get into details that aren't really relevant. But basically what this shows, there's a special non-standard, all right, let's see here. Let me just back away for one second. All right. Do you guys remember, and this would be so much easier if we were all in person, because I could see if people were just kind of zoning out right now, or if they were actually listening to me. Do you remember how we had, do you remember EER? Does people remember that EER? Extended Entity Relationship Diagrams? Where we had the ISA, and then what we presented as the options were that basically you can either kind of make each of the entity classes a separate table and then do joins between them, or you can just pound everything down and have null values in one giant wide table. I hope that makes sense to people. All right. That's kind of how you do it in relational databases. You make that decision. Now, there were some attempts to actually try to have that inheritance stuff built in to the fabric of SQL itself. And that you did that through inheritance. So you would have something like this. You would basically be able to say, like, created tables of cities, right? We have cities, and they have a name, a population, and elevation. And then we have a subclass of capitals, right? The capitals. And they have a state that they're a capital of. Okay. So this is kind of a contrived example, of course. No one would ever do it this way. But the idea then basically is that what you have the table cities, and this is a sub-table or subtype of city, which is a capital. And it has a special attribute called state. All right. So in PostgreSQL, you have this inherit city syntax, and then you get some stuff for that. But what you don't get is you don't get foreign keys, and you don't get enforcement of unique. And it doesn't really go all the way through. It was kind of a partial. It's very difficult to push this all the way through. So I would suggest that you do not use the inheritance. It's not standard. And I think there's better ways of dealing with it, and just dealing with it like we dealt with in the database, one class. And that is that you have basically either the ER method where you have multiple tables for each of the subclasses, or you just pound it all down into one wide table with null values. All right, that's it. I hope that made sense what I just said. But what I'm trying to say is I want to steer you away from, I'm saying that this is all good. All this is really good stuff, but I want to steer you away from inheritance. All right. There's another thing I want to steer you away from because it would, oh, I don't even want to get started. I've seen people do this and I just, this is terrible because you leave just a big pile of garbage behind for the next person who has to work on the project. And that is, I don't want to see you guys doing anything. I really strongly suggest that you do not do anything with creating your own types. Let's see here. I'll find it somewhere here, but please don't do that. Just pretend like it's not there. Okay, somebody probably would say, oh, but there might be, no, don't use it. And whatever you do, do not do composite types unless you really know what you're doing. I mean, there are always exceptions to these rules I'm saying, but you don't want to get somebody going in and doing this kind of stuff. I mean, you want to, it's like the whole principle is that you don't want to use too much. Like if somebody gives you this giant language, right? And you can accomplish what you need to get accomplished using the simplest constructs in language, use those. Don't go and do advanced stuff that makes things more abstract, more complicated, more like requires more understanding of the full standard to do if you don't need to. If you need to, do it. But if you don't need to don't do it. So don't create your own types or domains. Domains are particularly bad. But we'll probably come to that. Yeah, at one point I'll be able to kind of, if we went through here, I would be able to show you guys exactly what I did not want you to, what I don't want you to do. It's going to be down in here. All right, here's another thing, like table partitioning. This is really cool stuff, and we might be able to do table partitioning maybe on Recitation 2, but this is for like giganto databases. These are for databases, and when I in my own terminology, a giganto database is a database that's larger than main memory. All right, but most of the time, well, not all the time, but how often do you have a database that's larger than main memory that is that big? Well, you do if you, I suppose if you really, if you're Scott de Verket or something, you have one, but I don't think you guys are going to do anything with that kind of stuff, but it's kind of interesting. If you really want to, let's see here. Row security is kind of good to know. Modifying tables, let's see here. Exclusion constraints probably can be avoided. It can be. There's a lot of detail. There's a lot of very specific things here, but it's kind of worth knowing. So I really hope that you guys, maybe you're like thinking, God, what is he doing? He's just telling us to read the manual. Well, yeah, I kind of am actually. Yeah, so let's see here. Okay, let's go back to SQL here so we can see some details. That is, I'm going to go back to the slides. All right, let me share a different screen. Stop share here, and let me share a different screen. Share screen, and now we will share this screen. And this is kind of where we were at as we were going through SQL. All right, so let's get back to this here. All right, so as we all know, there's just the kind of insert, delete, and the let me move this. The updates. All right, so here's something that kind of can come up. It'll come up more often than you would expect. So you'll sometimes get these kind of issues. All right, so that what you do is you have some kind of circularity in the constraints. So this example here. So like by default, integrity constraints are checked after each insert, delete, and update operation, which can lead to some kind of immediate inconsistency. So let's talk about this in a second. So if you recall from the database 1 course or the equivalent that you guys took, we have the notion of like beginning a transaction, doing a set of operations, and then ending or committing the transaction. If you don't do that, then implicitly every single thing is its own separate transaction. So when you do an insert, so for instance, when I say here, so we have right here, we have department, which is a university department, and it has a head, and the head is a foreign key into instructor. That's like the head instructor. But then an instructor has a department, and that's a foreign key back to department. So we have circularity in the declaration of the foreign keys, right? And yeah, I mean, how would you go about doing this? So how would you be able to insert? So how do you insert the instructor in the department 000, which is a management department in the Ortega building? I'm sorry, instructor 000 with a name Ortega, who's in department management and has this salary. How do you insert them into? We have that. So as it turns out, Ortega is going to wind up being the head of the department. He's going to be the department head. So now we have the department here, and how do you actually wind up being able to kind of achieve this? So if I do this right here, if I do the insert right here, then there's no management here, so it's going to block because the foreign key management hasn't been included as a department yet. But what would be if somehow Ortega got in here? So if we basically did insert into instructor 000 Ortega and then null value here. Let's say instead we had a null value there for management. Then we could put it in. Then we could actually insert the department with management, Watson, the management in the Watson building with this budget, and then point back to instructor Ortega. And then we would have to have another operation where we change the null to management. Okay. That would be one way to solve it, but that's really not very clean. Okay, that's not very clean at all. So, so if you just want to keep it as two inserts and not like some update, then you have a little bit of a problem here because it's a chicken egg problem. I mean, you have to have an instructor to enter the department, but you have to have a department to enter the instructor. So what has to come first, the department or the instructor, right? You get the idea? So how do you deal with problems like that? So what you wind up doing it as an explicit transaction. So what you do is you say begin, and then you insert Ortega, and then you insert the department. So, but right here, because you wind up declaring these things here as deferrable, initially deferred, it allows you to not have to check for these integrity constraints in the middle of a transaction, right? So this will come up, absolutely this comes up, but what this is a keyword of basically saying when you actually, so you can create the table here and you can go and you can alter the table and you can add this constraint and you can put this constraint in also at the declaration time, but you just have to basically tag it as deferrable, initially deferred, right? And so this is kind of a syntax that kind of regulates that. So that's how you wind up being able to kind of solve those kind of problems. All right, so it's transactions, and it's also these keywords of allowing for constraints to be deferred while a transaction is in progress. Okay, so that's a good thing to know. And let's see, I want to say one thing about a general kind of way you work around these kind of things, or so typically here's how it works. I think that, I mean, you usually are given a database, or you have a database, or you're going to build a database from different sources. And one of the things you always want to make sure of is that when you do a dump, when you dump the database and then you recreate another database, new name database, and you suck the data back in, that dump and load cycle never gets corrupted or problematic. Because if it does, so if you don't set the constraints up right, you can have it so that you dump out all the data, and when you dump it, you just dump it into this giant text, basically this giant character file. And then great, so you dump all the data from the database into this giant character file, but let's say that you don't have it set up so that you're getting being able to defer the constraints. So then when you go, you have this giant amorphous, it's just this giant, and it's big, very, very big file. You create a new database, and then you try to load it back in, and it doesn't work. It wedges up somehow. that's a bad day that's a bad day for database people. That's a bad day. So a lot of times these things will come up in the context of that. They'll come up in the context of just rebuilding a database after maybe certain modifications or something. That's usually the context in which these things come up in practice. But what you'll see when it does the dump, it will block them off with transactions. And a lot of times you'll get this will work automatically, because the way when you do the dump out, it's smart enough to set the constraints up the proper way. All right, so I don't want to have people freak out about that, but it's not a bad idea sometimes to test that if you're working on a database that you need to share with somebody at one point, to do a dump and rebuild, and just to see if you haven't screwed things up so that you can't rebuild it. That's you want to make sure that doesn't happen. All right, so let's go on here. Cascading updates. All right, so I think we covered this in the first course, but there's this idea of this has to do with when you have foreign keys. What do you do when, so if I'm pointing a foreign key to something, and then what happens when that thing is deleted? So let's say that I'm an instructor, or I'm an instructor, and I'm pointing to some department, but then that department gets deleted. What happens? All right, so you can cascade it so then that I get deleted if that department gets deleted. You can cascade it so that my actual pointer out to my department turns into null. Okay, so those are your kind of two basic options. Third option, that is, you can basically block it. That is, you can block the delete of the department if there are still people who are members of that department. Okay, so these are all things that are set up to kind of keep to have things controllable to maintain referential integrity. Because one thing you would not want to do is you would not want to just delete the department and then have this dangling pointer out to some bad ID, right? That violates the foreign key, of course. So in other words, I'm left as an instructor pointing off to this old ID, and there is no row for that ID anymore. That you would not want. And SQL basically is going to make sure that doesn't happen. So SQL is always, when you have foreign keys, it's always going to enforce the referential integrity, right? Okay. So this probably is something that you all have gotten a taste of. Schema for the grading database. All right. So is there anybody who doesn't know what an outer join is? I mean, it's okay. You can put it. You can do a private. You can send me a private. You can send me a private chat, a private message. If you don't want to announce to the world that you don't know what an outer join is. All right. Well, I mean, if you read the documentation stuff, I mean, if you read this, you're going to get into outer joins. So I don't think that I need to go over this in such detail. But obviously, outer joins are, I mean, why do we even do, I mean, outer joins are just, from a logic point of view, outer joins are just syntactic sugar. Well, from a logic point of view. So in other words, you can always simulate outer joins with a union and check this for nulls, and you can pad things. But you want to have the outer join syntax, because then SQL can do it efficiently, and also it makes it so that the query expressions are much more compact. Let's see, just to kind of get some interaction here. Does anybody know? I mean, like, what would be a prototypical case where you would use an outer join? Wow, there's many cases. I'm trying to think of like you would have a good example of an outer join. I can think of a lot of cases where that are going to be too complicated if I start getting into, but outer joins. They'll come up. We'll see. We'll get a lot of motivation for those. All right, now a view. Views are outer joins are important, but views are even more important. So views are really, really critical. So what are views are virtual. So it's a virtual table which is constructed using a query, which is defined as a query. So we had this here, this instructor-student view here. which gives us, these are the, so instructor, student, and then we have the set of attributes in the view. Okay, but you don't need to have the set of attributes here, by the way, in this definition. And sometimes it's really nice to not have the set of sometimes it's really nice to actually be able to say create view, instructor, students, or whatever else you might want to have, and then not have this here so that you don't have to maintain it. Okay, so you just, so let's say we have a very large, complicated table or set of tables in a database. And what we want to do is we want to create, like, let's say, let's put it this way. So let's say that let's put this in the context of some real work or something. Let's say that what we had is we had just a whole bunch of dumps of CSV files from, let's say that someone says to us, we want to build a database of, we've been stuck on our kind of crappy system, and we want to go to a new system with lots of better definitions of the tables. And, we want to kind of, we have this legacy system, which is really crapola, and we want to go to this new system, right? We want to go to, we have our system in this old database that is, it's really limping along here, and we want to move to PostgreSQL, this new system or something. Okay, how are you gonna do that? Well, they're gonna basically export all of their data as CSVs, comma separated value files. And then for each of those files, you're going to import and you're going to make a table, right? And these can be really wide tables. And you might even grab like another Excel sheet and bring that in as a CSV, right? So you just define this kind of table space of all this junky data that got fed in from their legacy system, right? Or from data feeds or whatever else might be. I hope you guys are following. All right. So then you have all those kind of base tables, which have all their kind of idiosyncrasies, and they have all their wide attributes. And what you really want to do is you want to create a view expression, which does a union of separate queries over these. Like, let's say you want to pull out the contacts, and they have all these different things where different people's names and emails might be. And what you do is you have like one view over this particular table, which basically selects, and then you don't have to like, you can select the set of attributes you want to pull out of that CSV and define that as a view. This is really common use of view. And when you do that, a lot of times you don't want to have this, am I sharing my screen here? Yeah. Uh-oh, which screen am I sharing? You guys, you see the views up here, I'm assuming. You don't want to actually have to list the attributes because you want to keep everything kind of clean. So what you do is you just say create view, instructor, student, for instance, and then as, and then you actually have the select clause here that's going from the base table. All right, so that a lot of times you'll see yourself doing that. So this is actually something you don't want to do sometimes because it just becomes extra places where things can go wrong. Anyways, what views do is they define a mapping so that then when you actually say select star from instructor student, what PostgreSQL does, or the SQL processor does, is it just goes into your actual query expression and does a substitution. Everywhere it sees instructor student, it substitutes in this beast here, select, distinct, this whole thing. And because of lexical scoping, you don't have any clashes, right? Because there might be repeats of references down here, but they're not going to clash because each one is kind of expanded out separately. So doing view expansions is really it's an extremely elegant way to kind of go from a lot of crappy, badly defined data up into something that is really clean and is the model that you want to do the export to build the new database. This is very, very common. It's called a data dredging operation. So it's very useful, and you want to do this stuff with views. Okay, so that now when I say that, what I want to do is I want to refer you guys now, because we're about to take our break here. I want to refer you now back to material here. Let's go back here. I want to refer you back to material here, and I want you to look at this work here, cloud data management, because what you'll notice in there is that whole kind of use case I just talked about is exactly what they are exploring. They're promulgating in this right here. So there's a lot of work going on these days in using views and using in particular this tool called DBT, database build tool, to do exactly what I was just talking about. And it's gotten a lot of traction. And I think DBT, they just got like, I don't know how many hundreds of millions of dollars to go forth with. I don't know how they're gonna make their money, but that's not my business. It's the whole kind of venture capital world and all that. But the idea then of doing this, let's see if I can just show you guys here. Yeah, actually, if you just look right here, like right here, there we are. I suppose you guys can see this. But what you have here is you have the source of the data, and then you have what's called a data lake here, the data lake. And between and that, so this is like just the kind of like exporting of the chunk of the full data and just plopping it down inside the data lake, which is basically, the data lake is basically PostgreSQL. So all this stuff is being exported and plopped into PostgreSQL. And then you have a whole series of view transforms that will take you from the lake into what's called a data warehouse. And then you might further have view transforms that take you into these data marts. And this architecture here is really a kind of a critical this is the architecture that people are kind of rallying around now in databases to deliver analytics, to kind of deliver. I mean, you name the kind of you know, the new, like, you know, data centric organization. This is kind of the architecture, and it's a little bit different and interesting that it's kind of evolved a little bit from kind of what was best practice as of just like 5 or 10 years ago, but there's a new kind of practice around this, and I'll be talking about that a little bit when we talk about data warehouses. Okay, so I know that's whirlwind. I don't know if you, I mean, this lecture style, I'm sure is pretty, it's not standard how I'm doing this, but I mean, until you guys start complaining and saying, you know, you got to like give me feedback, because you remember, I don't get feedback from you guys like I would if we were lecturing in person. In person, if I was doing this and I could tell I was losing everybody and no one was interested, I would be able to kind of course correct. Okay, but I don't get that here really. So I rely on you to give me feedback because otherwise I'm just kind of flying blind. But okay, but maybe some of you guys find it useful, some of you guys don't. But it'd be nice to kind of get some feedback at least. To if you guys want me to change, because right now, I mean, speak now, because I can change my whole style of lecturing and everything. You know, there's still time to change in this course. All right, so I'll just look at the chats and see if I get any feedback during the break. So let's take our break now and get back at 11:20. Okay, all right, and I'll pause the record. All right, and stop the video. Okay. Oh. Okay, folks, I think we're back. I didn't get any feedback from anybody, but then again, I also didn't get a whole bunch of people dropping out. So I'll take that as positive feedback, because I mean, if a bunch of people would have just left, that's usually like the bad sign of things going sideways in lecture or on Zoom or something, is if you start babbling and then you start seeing the participants kind of just declining. So maybe at this point, if people want to leave, then they can kind of like say, oh, well, we were intending to leave. So, but I'll just kind of assume that you know, I'll just continue on. But again, if you want to if you want to change the way I do the, I mean, just I welcome feedback, negative, positive, whatever. I prefer, oh wait, I prefer feedback better, sorry, any kind of feedback better than no feedback at all. But anyways, let's go on. All right, views. So yeah, so you know, you can, the nice thing about views also just to kind of, so I mean, you might say something like, well, we have this data and, you know, they're using red, white, and blue, but we would like to actually have R, W, and B, or some even more complicated variations. You can use a case statement in your view to do the data transform, right? To change like the actual data values. So the value mapping, it can also be done via views. So the idea then is that everything should be done via a view when you're doing kind of a transform of data from one data source to another. You should do everything through a view. So the people at DBT, they're really kind of religious about this, and they don't even allow you to do deletes or modifications to underlying data. They want that all to be achieved via a view. I think that might be a little bit too much. So I think sometimes you need to go in and do like, you know, the data comes in and you know there's a whole bunch of data you don't even want, so you can just do some operations to clean it up. But what the problem with doing, if you look at the DBT folks, like the database build tool, so that was like Fishtown was the name of the company that was doing DBT, but now it's just DBT Labs. They changed the name. They talk about this notion of idempotency. So you remember, like, maybe you guys remember from like algebra or basic maths, this idea of idempotence. Idempotence. So what does idempotence mean? And why, you know, usually with idempotence, you always thought like, God, well, seems kind of idempotence. I believe I spelled that right. Idempotence. So people seen that before? Have you seen that before? Let me just make sure I'm just spelling it right here. I'll just do a Google search. Idempotence. There's a Wikipedia on idempotence. Big Wikipedia page about that. How many people remember like seeing that word before, idempotence? Anybody? Okay, good. We got at least one person raising their hand. So at least one person has heard remembers, and that also verifies that you guys can hear me. One person has heard the term item, or recalls hearing idempotence. So idempotence is kind of like, if you recall what it was kind of like, it was just kind of like this. If I say a op, so if I just basically say, I have an operator, let's just do a unary operator. Op, I'll make it D for database, equals op D. Right? So op is an idempotent operator if this is always the case. So in other words, if you apply it once, then you apply it anywhere from 1 to an infinity amount of times, you're always going to get, you know, you're always going to get the same result. So it doesn't keep on changing stuff. So there's a lot of things you can make updates like idempotent, but a lot of times they're not, because what they do is they crash the second time that you operate on them. So in other words, you delete some tuple where something, you know, but as far as the database state, I suppose it's idempotent. But if you say something like delete here's a classic example of something that's not idempotent. That is, if you take a list of all the people in the database and you have like, let's say you have the, next to them, you have like the salary or you know, whatever, and you want to delete the person with the lowest salary. And then so you have an operation that says basically find the person with the lowest salary and then delete that person. Not to say there's anything, you know, let's just turn it around. Okay, I'm just to show that there's no politics in here. Let's delete the person with the highest salary. Okay, so we go to we have an operation. What it does is it goes and it deletes the person with the highest salary. So it finds the max salary, it finds the person or people who have that max salary, and it deletes them. Okay, that is not idempotent, right? Because if you do it once, you'll get something new, and you do it again, you'll get something new, and you do it again, presumably you'll get something new until everybody's removed, and then it's completely empty, right? So that is not an idempotent operation. But you might say something like, well, deleting this particular tuple is idempotent in the sense that if you do it once, well, you can do it again and again and again. It won't make any change to the database state. Yeah. So that's right. So I see the comment here. Yeah. So yeah, it's an algebra. You'll see in algebra, there's the notion of idempotence. And what was the classic idempotent operation in algebra? I don't know. Yeah, it's in logic, it's in algebra, and it's also in databases. Because this notion of idempotence is actually quite critical when it comes to like doing transforms of data. So what you would like to do is you'd like to have your transformation be idempotent. That's what you want. You want if you're going to take a database, all these data sources, and you're going to define this operation that goes from all these data sources and then builds a new data source, you would like for that to be idempotent. Okay, to keep it, because the thing is that a lot of times when it's not, or when there's a lot of intricacy in it, it winds up being an absolute headache to manage. All right, so this if you look and you see kind of some of the background ideas to DBT, this database build tool, you'll see that idempotence comes up. So it's one of those things where, wow, okay, so we actually do have a use for, I mean, in logic and in algebra, in these classes, you think, wow, these are kind of interesting concepts and all that, but do they actually mean anything in the real world? And the answer is yes. In this case, idempotence becomes very meaningful when it comes to databases. All right, so views by definition are kind of idempotent. I mean, they're not even an operation. You're not even changing anything. You're just declaring a view, right? Okay, so it's kind of a very nice property by definition that way. But then if you're going to, so they try to sell this idea that you're going to do everything via views. I'm a bit more pragmatic, and I would say that, well, you're going to make changes to the database as it's coming in, because you want to get practical about these, and you don't have these gigantic weird view expansions. You'd like just to say delete those cities, all right, or just clean up the data in some way or another. You don't have to do it through a view. But when you're doing those operations of that cleanup, it better be idempotent. The way you define those updates better be idempotent, okay? Because otherwise, when you run the script, did you run it once? Did you run it twice? And it's going to make a difference if you ran it twice. All right, and that's what that lack of idempotency in an alter or an update operation would make it so that it would matter how many times you ran it. So that salary example I had is not a good way to do your deletes. Okay, try to make everything idempotent. All right, so there's a little bit of a connection to one of these big. These big letters, these big words. And it looks like I lost a participant on that discussion. So we'll see. I hope I don't lose. Maybe the next little tangent I go off of, I'll see, and then 2 drop off. Oh no. All right. Anyways, by the way, I have no idea who left. So I'm not tracking like, oh, I'm not gonna look at, I'm one of these people. My basic philosophy is you can call me anything you want as long as you call me for dinner. That's the old joke. So say whatever you want, just call me for dinner. So I know it's okay. Anyways, all right. Updates to views. So I'm trusting you guys can still see the screen share here. Yeah. Updates to views. Yeah. The answer to this is don't do it. Okay, you can do it. You can make it so that you have a view. So you build this kind of database up. Let's say you wind up defining. You take all these source data. You define a view that defines a new database. At that point, you might want to then, at that final point when the view has been defined, you might want to copy that all out into a fresh database. Now, why would you want to do that? A lot of reasons why you'd want to do that. One is that if you actually, all right. So what are the choices we have with a view? Let's get into this. When you define a view, you can just leave the view there and then not just use it as you wish. You can declare it to be a materialized view. So you remember this notion of doing materialized view. What that means is that the PostgreSQL itself will maintain. Well, you have to actually say rematerialize the view, but it will basically copy all the tuples into that view so that it can be a lot more quick to access the view. So it's basically the data values are there, and so you can just almost treat it like a table, grabbing from it. But it's not quite a table. Finally, what you can do is you can define a whole new schema, a whole new target schema, and then do an insert into that new schema, the tables in that new schema, using the definition of the view. And that makes it so that you actually do create a legitimate copy of the database through the views into their own tables. And what's nice about that then is that you can build indexes over those new tables, and they become their own database. And you can do things very efficiently. And you can also, if you want to, you can update the values in that database too as well. So you don't have to worry about this updated views problem. So updated views problem is something that if you do have a defined view, in some cases you can actually reflect it back, but in practice, no. make a new copy. Don't make a copy of the database. I don't know. I mean, updates of views. I mean, maybe some cases you're going to use that, but yeah, maybe. I don't know. I'm sure there's always use cases where it's like, oh yeah, that would actually be a case where you want that. Yeah. All right. So let's so we're done with views then at that point. Remember, views, leave them as a view, materialize them, or define a new table, and then copy everything from the view into that table. Those are basically your three options when it comes to how you're going to deal with your views. All right. And then you can bring up the whole idempotence question about it. You know, how does that relate? But anyways, null values. So the logic of null values. So null values, as you recall from the database one class, is that nulls. SQL is based on a three-value logic. Basically, things can be true, false, or unknown. And basically, you have the three-value truth table here, and that kind of builds up compositionally from here. So yeah. So this is basically how SQL is going to deal with your null values, and this kind of shows an example of how this, in principle, can lead you astray, but you have to use negation. So negation over nulls is what causes the problem. So from Lipkin, he showed this kind of very simple example here, where we have the two tables R and S, and give me the A's where there does not exist S that equals A. Now, if S if it has a null value, then that could actually, so null value, logically what you can do with null values, you can turn them into basically just open variable, free variables that could be assigned to something. So in principle, I mean, this determines that we don't know what the value of, or it's missing what the value of A is in S. So it could be 1. It could be 1. But when you say, give me the values in R where there does not exist something, where there does not exist a matching S, and we have 1 here, then this actually will give you back in SQL, this will give you back the false positive 1. Because the truth is, this should just be empty. Because you don't know, you cannot guarantee. So if you think about it, if you just look at this thing, I'm not really sure how many people can just look at this thing and get why this is incorrect. But this is what SQL will give you. So it is incorrect. So SQL, when you have null values in SQL, you can get an incorrect answer. And here is an example of that from Lipkin. So there's an old saying that says basically, and it's an academic argument. It says that, well, you cannot trust the results of any database that contains a null value. And strictly speaking, that I suppose is true. But we do all the time. It's just we don't ask questions like this. So basically what you should be reset is that if you have nulls in your database, there are questions you can ask, but if you ask them, why are you asking them? I mean, is there a reason why you're asking them? But if you do ask them, you can get a incorrect response, right? And it involves some kind of intricate use of it involves a negation, and that's where the trouble comes. So if you look at this right here, you can basically. So what I'm trying to tell you guys is don't have this completely shake your whole confidence in SQL, and then thus shake your whole confidence in the modern society backed by databases. It's okay, all right. We'll be okay. It's unless people start asking questions like this, and then we won't be. If you depend, if you determine whether or not something happens in the real world based on a question like that, then you might be in trouble. And then of course there was the example we had just where if you have nulls in the value for A here, then getting all the A's from R will be different than getting all the. I should make this a star. Select star from R will not equal select star from R, where A is greater than 10 or A is less than or equal to 10. And so strictly speaking, this is also false, because what the null value represents for A is that it could be, in this case, I mean, it could be like, it's going to be a value, we just don't know what it is. All right. And so therefore, if it was the value happened to be 6, then it should basically say then that we should return this should be a star here. instead of r dot a, I have to make a note of changing that to star. R dot a left to star on slide 55. Okay, all right. So I hope that makes some sense and kind of gives you a little, some intuition. I mean, most I think what the lectures are about is just giving you intuition and some confidence, because you'll hear me kind of at least reason these things through, and you might say that, well, all right, that this is how somebody who's familiar with the stuff looks at it. So yeah, so maybe there's some value in what I'm doing here. All right, let's go on then. Present as a slideshow. So I assume you guys can see this, and if you don't, I assume that you would complain on the chat. Where's the chat? Where did it go to? Oh, here, chat. Where did Mr. Chat go to? I've got the there it is. All right, got that back because I needed that. All right, so now we're gonna kind of go into a bunch of stuff that you probably didn't see in the Database 1 course, but let's just kind of go through this. Some of you did actually see in the Database 1 course. What do we talk about here? Functions, triggers, and recursion. Recursion you saw, so we'll probably not go into that so much. Okay, so it's possible to call procedures and functions directly from SQL. Now, procedures and functions they're both together what are called routines. And what it is basically, it's like, I think it comes back from, I think it inherits from Pascal or one of these old languages, procedure and function. Yeah. So basically what a procedure is it doesn't return a value. It's just like you call the thing and then it does something. You could call stuff by reference and then it might change what it is that you're doing in the reference, right? And then therefore making side effects. But it's not, doesn't strictly speaking return anything back. A function, however, is always important. A function is meant to return something back. You call a function to get something back from the function, to get a return from the function. And I'm assuming you guys all know this from functional programming or what you guys get of functional programming. Have you guys got any functional programming? Have you guys got any, I mean, I don't know. It's like the lambda. I mean, you go to the lambda calculus, all that stuff, but functional, yeah, good. So you guys have some function. So functional programming actually is really, really actually, yeah, a bit of Haskell, good. Some people have some Haskell, some Scala, yeah, so good. All right, so you guys got, at least, some of you guys at least have tasted a little bit of the functional programming stuff. So so of course we have that whole idea of side effecting. So a function that side effects, or in this case, a procedure that might side effects. Procedures kind of are going to side effect by definition almost. That's something that we would like to avoid if possible. And then there's also like, I mean, there are going to be functions that are kind of immutable. So in other words, no matter whatever goes into the function, whatever the arguments into the function are, the result that comes back out will always be the same. All right. Now, certain functions, if the function determines on anything in the state that's not, if it's reaching out and getting something in the state. So for instance, let's say that we had a function that basically says, okay, on Tuesday, if you give it 1 and 1, it'll add them. But on any day other than Tuesday, it'll multiply them. That is not a immutable function, right? I mean, that's a function that's going to change based on what day of the week it is, right? So, those are different than a function. Let's say this, let's just take the function of this. I mean, it's such a simple example. It's about as simple as it gets. The function that takes two numbers and adds them together. That's immutable. So it's always, if you give it the same two inputs on whatever day of the week, whatever time, and it's always going to give you back the same result, right? So what's in an immutable function? What's the advantage of that? What's good about that? Is there any advantage to that in an immutable function? I'm just trying to get some idea about, like, let's I mean, get you guys to think a little bit on your feet. Why would we have an immutable function? Why would we want to have a function? Why would we want to make a distinction between immutable function? All right, they're safe to use. Yeah, I guess, but maybe let's say that, I mean, safe to use in the sense that, but that one that added the numbers on Tuesday, but then it would multiply the numbers on any day other than Tuesday, that's safe to use also, isn't it? I mean, it feels safe. I mean, it's simple enough at least. Depends what you mean by safe. I mean, safety has a lot of different meanings, but I'm not really sure. I'm not really going after safe.
What else is there? Is there anything else that you could do with an immutable function? Yeah, there we go. That's the answer essentially. So you know which result you can expect from them. That's kind of the answer. All right. Well, what the answer to this, is there anybody else who wants to give that's definitely on the way toward the answer that I'm looking for. Of course, I mean, it's kind of lame for like, somebody who's a quote professor asks some question that they know they want the answer to, and then the students have to sit there and kind of guess and guess and guess until finally they get it right. And then the idiot says, well, yeah, no, that's what, no, listen. But what I'm after here is the following. With immutable functions, what happens, you don't have to call an immutable function 10,000 times. You only have to call it once and save the result. And then you just have like this little structure that says, if I already have the result, you can do what they call memoize. You can memoize the function. Does that make sense? Do people understand? To memoize a function? To memoize. It's maybe an old term. Yeah, good. Okay, so memoize means basically what you do is if you know the function's immutable, then yeah, it's like a cache. You could say it's like a cache, exactly. So yeah, it's like a cache. The same principle as a cache, right? Exactly. Well, caches are a bit more complicated because caches have the idea of like, you can do something that can trigger the cache update. But it's essentially like a cache, yeah, exactly. So that's very good though, because if it's complicated, let's say it's doing a complicated calculation, if you could just save off, like basically what you're doing is you're trading time for space. So you have some space where you're basically saving off all the arguments. So that can take up some resources, but a lot of times it's just going to, since you can do hash access into whatever the list is, you essentially, it's a without memoization. If we didn't have memoization, I don't know, but I'm guessing without using this kind of idea behind stuff, the whole world would break apart at this point. It would all fall apart. I mean, all the internet. I mean, no. So this idea is so critical to kind of performance. So in databases, when I say performance, what do I mean? Performance means speed. Performance is always kind of means I'm talking about the runtime performance. So all right, so that's just something to keep in mind that we have this notion. I just saw here this procedures and functions. I just want to talk a little bit about functional programming for a second. But it was a bit of an aside. Did I lose anybody? No, still got 19 participants. All right. So anyways, we're going to focus on functions here, not procedures, just functions. So basically, you have two options so you can create functions inside of PostgreSQL. So you can do create function, and then you give it a name, and then you say as, just like a view, create the name of the view as, and then a big long string that defines it. Okay, a big long string, and that string is kind of like big, and it could be complicated because it's kind of like all the structure of the programming language inside of it. So we got to deal with that. That's one thing we have to deal with, and we're going to find out there's an easy way to doing that. But when you look at the syntax of these things, you're going to find out, why strictly speaking, why are those $2 signs? What the hell does that mean? Well, because it's a big long string that is then going to get pulled in and then dealt with inside of PostgreSQL, but I'm getting a little ahead of myself here. So you can do them in straight SQL. You can define functions in straight SQL, but that's kind of, that's not very much power. It's just SQL, right? So, okay, well, I can do that also by just writing bigger SQL. But what we're looking for here is we want to have what are also called stored procedures, which function stored procedures are kind of synonymous. We want to actually be able to store programs as data in the database, okay? And we want to be able to create functions. And when we're talking about creating functions, we're talking about creating complicated functions that do a lot of, interesting, important thing. I mean, if you've noticed, I changed the logo of this, of the course to the matrix. I'm not sure how many people caught that, but so we're not going to have functions like, who was it? Like the key, like, what was it? The key maker? I mean, we're not going to have like really super complicated functions like that, like the key maker. But again, I wanted just to tell you guys, if you haven't heard before me say this, but if you were going to implement the matrix, if we're going to put everybody in these like little boxes and use them as batteries, we are going to absolutely implement this as a relational database. Okay, if we're going to build a matrix, we're going to do it as a relational database. I know of no other option. You might say, oh, well, we can maybe some of these third-person shooter games, maybe. But I'm thinking immersion between third-person shooters and virtual reality and databases. It's got to be done logically. We can't just do this as a big kind of gobbledygook of code, right? So we need to control the code and store it off in places, and we can do that through stored procedures. Okay, so that's what we're at. This is the science fiction. This is what we're after here, to turn everybody into a battery. For the benefit of the artificial intelligence, of course. I mean, it's not a very uplifting vision, I suppose, but it is technically sweet. So let's go with it. That's kind of how I see it. All right. Standards and realities already discussed. SQL implementations are not known for their close compliance. All right, defining functions in standard SQL. That's just defining functions in PostgreSQL. Here's where we're going to get into something. Okay, so this right here is a function. So this is kind of one of those boring functions I was talking about, which is basically just based on SQL. But what we got here is we have, like, at least we see here, create or replace function. So you want to put this extra syntax in there for obvious reasons. What does this do? Let's just relate this back. If I say create or replace function, what this does then is it makes it so that when I do in PostgreSQL, when I load it in and I load it in again, if I just have create, it's going to cause all these annoying error messages to come up. So you always want to have on your views, you want to always have create or replace, right? Because that way you get the same behavior every time you run the thing. It doesn't, I'm not going to say idempotent. All right. Because that would be abusing a little bit of what the meaning of idempotent is. All right, now, if you see this right here, it says, create this function, blah, blah, returns big and as, right? Okay, this as right here, this is the string. So this in PostgreSQL, $$ is just like in Python. It's kind of like that, the 3 quotes in Python, which mean basically we're going to have a multi-line string. It's the same kind of thing that's going on inside of PostgreSQL. So that's when you see those $2 that just means the string. So it's basically having it so that this whole thing here, starting here to here, is what the actual function will be defined as, and it will be defined in the language SQL. All right, but the language we really want to use is not that. The language we really want to use is this more for real language, which is based on Oracle's, let's see here. It's called PL/PGSQL. All right. Now there's another language that was called PL/SQL, and that was Oracle's, the Oracle Corporation's, their server-side language, right? So this is kind of a knockoff, essentially. It's a knockoff of Oracle's PL/SQL. Okay, so what is it, and why is it a good thing? First of all, so instead of in language here, you basically name it there. So what it is, it's a full, like, Turing complete, full featured programming language. Apparently it derives from Ada, which I never used, but that's historically, its roots are in Ada or Ada. It's got a lot of things that you can do inside of it. So I've actually done a lot of programming in this language over the years. So I feel pretty experienced with it, actually. But let's think about it for 1 second. Let's just motivate it a little bit more here. So I just want to get so that you guys see why would you do this? What are the, okay, again, here it is. Here I am fishing for, like, this one correct answer, and then you guys probably are not going to answer me because you want to say, you don't want to be the one who says the wrong thing. And I said, well, no, it's not quite that. But let me just go through the routine here. All right. Why would you want to have, look, I could have a function inside my client program, right? I have this, let's take Scott DeVerket. Okay. Scott DeVerket takes, like, a bunch of data. It lets you, first of all, you fill in your record and you say kind of what your activities are and everything like that. And then what happens is it takes a lot of that data from your record and it starts tabulating out a full like tax bill, right? Okay. And then it's going to plop that out maybe into back into a record inside there, and then it's going to send you a bill, right? That's how it works. And yeah, I mean, you know, like death and taxes, right? I mean, these are things that are unavoidable because, you know, just the way it is, right? So so I commend tax. I mean, this has to happen. Okay, fine, no problem. So why don't we just say that? Let's keep the data. Let's have the data in I mean, I'm sure they're using Oracle, but you know, let's just say that they're using PostgreSQL just for, you know. So why don't I just like write some code in Python or write some code in JavaScript that does that pulls from the record, does the tabulation, because I like doing my calculations in like a modern host language. I mean, I'm looking over here at this function in PGSQL, and I'm thinking that looks like, that doesn't look so, I mean, I don't want to program in that thing, that's, what is this cruddy language here? Why do I want to do stuff in that cruddy language? All right. Well, why do I mean? You know, actually, it's not a bad language. I mean, I shouldn't beat up on it. Actually, there's a lot of nice things about it, actually. But why don't I just write this in the client? I mean, why don't I just have a host program that goes through and does the tabulation in the client, or maybe even as a script? Is there any reason why? Is there any advantage in doing it in the server? Can anybody think? Is there any advantage of doing this in the server? Because this PLPGSQL code, it runs inside the server, right? So it's running right there inside the database. I can call a function. I can call a function on a person in the Scott DeBerka database, and then it's going to then do a whole bunch of calculation internally inside the server, and it's going to get a number, and it's going to plop that into one of the attributes on that person, like their tax bill for the year. That's one way of doing it. Another way of doing it is to have a client in a host language call in, bring all the data in, do a complicated calculation, get the number, and then plop that back into the Scott DeBerka's. All right, maybe because it's already integrated into the data DBMS. Yeah, so I mean, there's a kind of a feeling of like, why like bring in? Why does the client have anything to do with this? You know? There we go. Boom. No network overhead. Exactly. So no round tripping. You don't have to like bring all this stuff in, do all the calculation, and send it back. I mean, you know, we've got like 10 million people, and we got to get the thing calculated stat. You know, I don't want to run this client doing all this junk going back and forth, back and forth, back and forth, and then somebody, of course, you know, screwed up and they didn't do it. They didn't encrypt. And then, you know, so it's somebody's getting packets, right? Okay, so that's nice. No, but of course, they're not going to be that. They're not going to be dumb, and they're going to encrypt it, right? How do you? What would that mean to encrypt that over? So these packets are going to be going back and forth to the client. They better be encrypted, so they better be, you know, better be HTTPS, not HTTP, right? Because HTTP, man, you're going to have trouble. Of course, I think transport still is, and didn't they? I think there was like, I think people were sending email with like database attachments or something. I don't know, like spreadsheet attachments. God only knows, but you know. All right, what else is there? Minimize data sent between server and client. Yep, that's right. Anything else? Is there any other reason? Yeah, you guys, the main, you hit the main reason right on the noggin. Boom, you got it. But there's another one also that I just want to kind of mention. And yeah, security, that's one. Let's just assume that's kind of off to the side. Although security, how do you do security? Security is always, every time you, oh yeah, there's another one too. Performance, well, network performance, it's kind of wrapped up in network performance. But yeah, okay. But it might also be just kind of like this, there's what they call the impedance mismatch. Let me write that down. This is, I mean, you hardly ever hear this. And if you say this out in industry, they'll look at you like you're like impedance This I probably did spell it wrong. Mismatch. I mean, if you really want to like get people, I mean, the thing is, you guys, I mean, if you're an academic and you go out and you talk to people in the industry and you start tossing around words like impedance mismatch, you are very, very quickly going to make them annoyed, because they're going to think you're like some kind of snob because you're using these big words for something that's kind of like, let's see here, impedance mismatch. So sometimes, you know, you got to watch it with those big words. You know, I mean, you know, you get annoyed. I mean, when someone's like, you know, when some pinhead is sitting there trying to, you know, kind of pull rank on you by using some big word, then, you know, there it is, impedance mismatch. All right. I guess it comes from electrical engineering. But anyways, in databases, what impedance mismatch, you know, if you want to try, you know, rattling that off at some meeting. It means that basically you have this mismatch between the host language, like a Python or, you know, a regular programming language, and the database language. Like things have to kind of turn into SQL. Then you got to like, first of all, you make a connection. And then you have the database environment. God only knows what's happening there. Make a connection. Then you send in a command. You get back a cursor, and then you got to kind of run that, you know, as an iterator. And then you got to go through that cursor and pull out the data. So there's this kind of block between the host language and SQL, and there's some other things also. One thing is that SQL is value oriented, whereas host languages are typically object oriented. I could get into that, but there's, you know, that's now I'm not going to get into that now. All right. So, but anyways, so you do have this impedance mismatch between the host language and the SQL database language. So if I mean, strictly speaking, you do not have that impedance mismatch when you go to PL/PG/SQL, because it's kind of integrated in, and you're using SQL as kind of first-class objects and cursors. It's all very, very tied, very close to the database. So you don't really have impedance mismatch, as opposed to like integrating a normal language, programming language, in with the database. Then you have impedance mismatch. So that is something, and I think that maybe is something to say. There's beyond network, there is also other performance and kind of logistical issues with, and just kind of human factors issues. But there's another one that no one's mentioned yet, or have they? Let's see, impedance mismatch. What does that mean? Yeah, I hope I described what it meant. Impedance mismatch. All right, it's kind of, you're probably going to think, well, all right, yeah, sure, Michael. But there's one thing also that has to do with what happens if Scott DeVericat decides that they want to change the rates ever so slightly in one particular commune or another, or whatever it might be. If you have one spot and only one spot where the function is defined, then you don't have this nightmare situation of you distributed all that client code out to all those clients, right? And then you want to change one little thing inside of it, right? Now you're really going to have a headache, because you're going to have to, like, I mean, you're going to have multiple. Do people say, I mean, if you put things on the client, then what's going to happen when you get a new version of the client? All right. Then you have to manage different versions of the client, right? And then, you know, I mean, for some people, I mean, now I will kind of, that's not political, but I will make a statement. And that is, in some places, and this happens in industry as well, so it doesn't happen just anywhere, it happens a lot of places. Some people kind of say, yeah, all right, fine. We got more to do now. Yeah, okay, fine. So we can accept the fact that we have multiple clients, you know, because actually it's kind of like, okay, Smith, you do with this older client, I'll do with the intermediate client, and then Jones will do with the absolute newest client. And we have three people, count them, three people doing the job that, if we were smart, could have been done by a half a person at least, right? Maybe. I mean, so maybe it's better to write it as clients. I don't know. I mean, no, don't ask me, but I'm just saying, from a technical point of view, it's kind of nicer to have it as a server side. I hope you guys understand and see why. Do you see how it might be less work if you have it on the server side? Can you see that? Yeah, I'm assuming you guys can see that. All right. What are some of the downsides to doing it on the server side? Well, you got to work with the language. It's a little bit more tricky. The debugging environments are a little more difficult on server side languages inside the database. But but it's enough, there's enough motivation there so that there's a lot of people who do server-side database programming, and it's one of those things where they say, well, why do the people on the client, so there's always these people who work on the client side, like this has to do with more like the front end versus the back end on the technical stacks, all that. But some front end people always complain, why do the server side people tend to get paid so much more money? I don't know. I can't answer that question, but I can say this. I can say that client side can be really fun, but server side is kind of so if you're going to do server side database stuff, you're going to have to learn a language like PL, PG, SQL. It's definitely part of it. So we're going to kind of go into that bit, and we're going to try to develop some of those skills in the first recitation. So you'll be getting an assignment to do some PL, PG, SQL programming to get you warmed up on that. So I don't know how far we really got with this. Time's up, it seems. This PL, PG, SQL, there's a chapter in the documentations that I would like for you guys to read. We're also going to be talking next time. We'll take this up next time about triggers. So what triggers are, so a lot of times when we say, let me just kind of quickly say this. I'm sorry I'm going over, but a lot of times it says, okay, you got a function in there. I can explicitly call the function with an SQL statement, but it's also nice that I can kick off these functions by having conditions that are met as tuples come in. So maybe there's a whole complicated function that should run if the if you have like a database that's controlling the nuclear power plant, and like the temperature or pressure in a certain area goes above or below something, maybe certain functions should, just based on the data, certain functions should be called, like maybe one that sounds an alarm, or one that kind of pulls back the rods, or I don't know, you gotta be careful with that. I mean, I saw the Chernobyl docudrama, and apparently I think when they pulled him back, I can't remember, they pulled him in and whatever, the thing went boom. So you got to be careful with that whole thing. But maybe. But the point is that you call a function based on conditions that are going on inside the thing without somebody explicitly calling a function. It's more that it gets triggered by certain values or certain patterns being met inside the data itself, which then decides to call the function. So that's what a trigger does, and we'll cover that next time. Okay, guys. Sorry I went over. Sorry I rambled. If I did, give me feedback. If we were all in the same room, I would get much better feel. Sorry for going over. Yeah. So, any questions? Just put them in the chat. Otherwise, I'll just assume that we can all go now. So I see 18 now. So it looks like people are trailing off. Yep, there we are. So I'll stop recording.